Swayam Prabha. Digital India. Educated India.
I am Dr. Rajiv Mishra, working as Professor Computer Science and Engineering at Indian Institute of Technology, Patna. The title of today's lecture is Mobile Edge Computing (MEC). So, we have already seen edge computing, and today we are going to extend this use case for mobile applications, and therefore, this particular topic is called Mobile Edge Computing, popularly known as MEC. So, in this lecture we will talk about great details of mobile edge computing. So, let us go ahead and introduce this particular topic. So, here we can see that evolution of mobile user equipments such as smartphones, laptops, they go hand in hand with the evolution of new mobile applications. So, as you see, there are a lot of new mobile applications are coming up, and this is being enabled with the help of upcoming technologies. And one such technology today we are going to cover is called MEC. So, however, running these computationally demanding applications, they are called mobile applications, at user equipments that is called smartphones or a laptop is constrained by limited battery capacity and often the energy consumption of that user equipment. As you know that we have to keep on charging the smartphones often again and again if we are running such mobile applications in the user equipment, that is smartphones. So, therefore, these mobile equipments are constrained by the limited battery capacity and also often constrained by the energy consumption, which is allowed to run this particular application in the user equipments. So, what is the solution? So, the solution is to extend the battery lifetime of these user equipments, yet you want to run these new mobile applications. So, that solution to extend the battery lifetime of user equipments while you are running the new mobile applications is to offload these applications, which demands huge processing requirement to the conventional centralized cloud. One way is this, that is the user equipment that is called smartphone, they can offload their task to the cloud. This is one way, that is called offloading. So, when it is offloaded, then the applications will do the execution on the cloud and thereby saving this particular energy. However, this option introduces significant execution delay consisting of delivery of offloaded applications to the cloud and back the time. So, we have already seen this is called round trip time. So, if let us say that your application or the user equipment requires or he can wait or it can wait a little longer time, then it can save the energy. So, this particular time is called round trip time. That is the time it takes to offload the applications to the cloud, consists of execution delay of delivery of offloaded applications to the cloud, sending it to the cloud for execution and getting the result back is called execution delay. So, this round trip time is the main contributor in executing delay. If let us say that this particular offloading is to be happening in the user equipment to run the mobile applications. Now, such a delay is inconvenient sometimes and make the offloading unsuitable for the real time applications. For example, if you are going to use some kind of app which is giving you some kind of service. So, it has to be computed in the real time. So, such real time applications are often this particular delay is inconvenient and makes these offloading unsuitable. So, this is some of the cases. This is not the way to solve the limited energy, limited battery capacity and energy consumption of the user equipments. Now, to cope up this particular delay, a new emerging concept known as mobile edge computing has been introduced. Now, this mobile edge computing brings the computation and storage to the edge of the mobile network, enabling it to run the highly demanding applications at the user equipment while meeting the strict deadline. Meaning to say that instead of sending the execution task or the task offloaded out of user equipment that is limited, having the limited battery capacity and reduce the energy consumption, but it is going to incur the delay. So, instead of that, why not we bring the compute services or the services which the cloud computing offers to a very close by to the user equipment, and this technology we know as the edge computing. But if we are using this edge computing for this mobile application, we call it at mobile edge computing or MEC. So, mobile edge computing means that applying the concepts of edge computing in the mobile applications or in the mobile services. So, mobile edge computing brings the computation and storage resources to the edge of the mobile network, and enabling this particular proximity to run the highly demanding applications at the user equipments while meeting the strict deadline requirement. So, now we are going to see this particular magic technology which is called mobile edge computing, which is going to solve a major problem, and everyone is now the user of the smartphone. So, therefore, this particular mobile edge computing is a technology of running the applications on the mobile phone, yet it is having the limited battery capacity and energy consumption all together. Considering this particular technology is enabler for supporting the new applications to run on the user equipments. So, we are going to see the how edge computing can be brought into the mobile networks. So, that means mobile networks So, the edge computing for mobile networks, how that is being enabled in this particular lecture we are going to see, and this is called mobile edge computing. I hope you have understood what is MEC, and now we are going to see the underlying concept and the principles, how the edge computing principles is applied to the mobile network, and bringing into this particular concepts of mobile edge computing, which is nowadays very much in discussion with the launching of 5G services. So, in the 5G services you might have seen that running any mobile applications is quite fast, and how this is all being possible is with the help of this edge computing, which is applied to the mobile network, called mobile edge computing, which is supported in 5G service, and prior services were not having this kind of capabilities, that is 4G was not having. So, let us get started looking into the more details of mobile edge computing. So, mobile edge computing places computing capabilities and the service environment at the edge of the cellular network. When you say edge of a cellular network, that means very close to the user equipment. So, this is the responsibility of a mobile service provider, or that is called the cellular operator. You might know popularly known as Reliance, Airtel. Now, they are adopting this mobile edge computing technologies, and thereby they are placing the computing capabilities very close by at the edge of the cellular networks. Now, this particular mobile edge computing is designed to provide low latency. Low latency means you do not have to now wait for processing at the cloud, context and the location awareness and higher bandwidth. So, context means if let us say that everything is computed very close by. So, context is preserved. Similarly, the location also is aware, that means you are not sending to the cloud where location awareness is not there, and also you are lowering the higher bandwidth usage, because there is no way you are sending the tasks for, or you are offloading the task to the cloud, but it will remain with the cellular operator very close by. So, this is the concept of a mobile edge computing to lower the latency, context and location awareness and higher bandwidth. So, all these things are now made enable using the mobile edge computing. How that is we are going to look upon. Now, deploying these edge servers on the cellular base station allows the users to deploy the new application and services flexibly and quickly. So, this is one of the major task here, that how to deploy, where to deploy these edge servers on the cellular base stations. So, this particular mobile edge computing architectures we will look upon that how this deployment of edge servers will bring into the benefit to the users, so that they may deploy their new applications and services flexibly and quickly. Now, there are many architectures, there are many possibilities of this deploying edge server. So, what is the standard for that? So, the standard organization called European Telecommunication Standard Institute, that is ETSI, further extend this terminology of MEC from mobile edge computing to multi-access edge computing by accommodating more, that is wireless communication technologies such as Wi-Fi and so on. So, you see that there is a standard organization called European Telecommunication Standards Institute called ETSI is also enabling to standardize, not only enabling the other communication technologies for this mobile edge computing, but also it will also standardize how you are going to deploy the edge servers, what is the architecture, so that it will be very close to the cellular base station, that we will see in this particular lecture. So, let us go ahead in more details after seeing these kind of requirements. So, mobile edge computing or MEC brings the computation and storage close to the edge of the mobile network, and thereby enabling to run highly demanding applications at the user equipments while meeting the strict deadline requirement. Now, running these highly demanding applications, what are they demanding? These resources like high demanding these applications, which requires a higher computation and higher storage resources called high demanding applications, are now possible to run in a constrained devices like user equipment using this particular technology called MEC. Therefore, in this lecture we are going to see what are the major use case and reference scenarios where this MEC is applicable. Then we will look upon how the MEC computing resources can be exploited also by the operators and third parties for specific purposes. Now, you know that in the mobile network, there are several stakeholders, they are the operators, third party and the customers. So, all of them, how we will see that mobile edge computing resources can be exploited by all of them. Now, existing concepts integrating these mobile edge computing functionalities to the mobile network, we are going to see that how that is being applicable, and we will also discuss the current advancement in the standardization of mobile edge computing. Here we shall also discuss the user oriented use case in mobile edge computing, that is computation offloading. In this regard, we will talk about 3 key areas, that is decision on computation offloading, then allocation of computing resources within the MEC and the mobility management. So, these are the important requirements or specifications, technical specifications of mobile edge computing, which makes it different from simple edge computing. Now, let us see that now we are going to see the contrast between MCC and MEC. So, MCC and MEC, here there is a word C in the middle is different. Here this C stands for the cloud and here this E stands for the edge. So, the earlier technologies which mobile network follows is called MCC, and now today the technology which is being followed by mobile network is called MEC. So, today's technology which mobile or cellular operator uses called 5G, and earlier technology was 4G. So, let us get started here by seeing all that. So, these demanding services or the applications by these mobile phones are more and more powerful in terms of requirements of the CPU or the processing. Even these may not be able to handle the applications requiring the huge processing power in the short span of time. Moreover, these high battery consumption still poses a significant obstacle restricting the users to fully enjoy the highly demanding applications on their devices. Now, this motivates the development of mobile cloud computing called MCC. So, the full form of MCC is mobile cloud computing. So, that means user equipment UE now is complemented with the cloud, and this together is called mobile cloud computing, allowing the cloud computing for mobile networks or mobile users. In mobile cloud computing, a user equipment may exploit the computing and storage resources of the powerful but decentralized computing clouds. So, they are accessible through the core network. So, how to reach that? This is called the core network. Core network of the mobile operator and the internet. So, therefore, MCC often brings several advantages. We are talking about 4G. What are the advantages? Using MCC has several advantages. It will extend the battery lifetime by offloading the energy consuming computation to the cloud, enabling the sophisticated applications to run on the mobile users. Third is providing a higher data storage capabilities to the users of the mobile phone. Now, this MCC also imposes huge additional load both on the radio and the backhaul of the mobile networks, and introduces a very high latency, since the data has to be sent to the powerful servers, that is the cloud, that are in terms of network topology quite far away from the users. So, here this we are talking about. Now, to address To address the problems of long latency, these cloud services should be moved to the proximity of the user equipment, that is to the edge of the mobile network, as considered to the newly emerged edge computing paradigm. So, instead of cloud, we are now making the transition to the edge computing paradigm to be included, to be inducted into the mobile network, and thereby this is very much required for latency sensitive applications. So, new kind of applications which are called latency sensitive applications are now possible with this MEC, which was not earlier possible with MCC. So, in the case of edge computing, the computing and the storage resources are supposed to be in the proximity of the user equipment in the sense of the network topology. Hence, these MEC can offer significantly lower latencies, jitter, compared to the MCC. So, these are the other side advantages which MEC provides, that is lower latencies and jitter, lower jitter compared to the MCC. So, if you make a comparison of all that, we will see the advantages of MEC over MCC. Moreover, while the MCC is fully centralized approach with the forms of computers placed at one few locations, edge computing is supposed to be deployed in a fully distributed manner, that we already know. Now, on the other hand, the edge computing provides only limited computational and storage resources with respect to MCC. Therefore, if we make this comparison between MCC and the edge computing, what we found is that MCC is based on the computing cloud services, and whereas MEC, so this comparison is between MCC and MEC, which is nothing but applying the edge computing. So, let us see that deployment here, that particular cloud is centralized, whereas MEC is having a decentralized. So, when you say decentralized, it has different advantages, that means compute and storage is in the close proximity of user equipment. So, and the distributed concept also provides the scalability. Scalability means now there is a capacity, you can add more devices to get this particular kind of service with very high speed and low latency. So, these are all different advantages if you make a transition from MCC to MEC. So, this deployment we have seen, then distance to the user equipment of the mobile of the cloud is quite high, whereas for the edge this computing or providing the compute and the storage is very low. Latency also is very high in the cloud services because of round trip time, and here it is quite low because that particular communication is avoided. Now, if communication is avoided, then you can also see the bandwidth requirement. So, here it is bandwidth requirement is low and it is quite high. One more factor if you see. Now, jitter or the noise is quite high. Why? Because it has to travel over the network long haul. Here it is quite low. Computational power is concerned, here in the cloud it is ample, that means unlimited, where the edge computing is having the limited computational power, but with the low latency, and this is having enormous computing power with high latency. Storage capacity also has the high capacity, is ample of capacity, but with a high latency, whereas the edge computing has this limited storage capacity with very low or ultra low latency. Bandwidth also is required too much, very high in case of MCC and very low bandwidth requirement. So, these are all comparisons, and therefore, this new technology called MEC has far more advantages compared to the. Now, it is started, mobile edge computing is started by applying different paradigms. So, we will see one by one what are the paradigms of edge computing which are applicable at the mobile edge computing. So, the first edge computing concept bringing the computation and storage very closer to the user equipment was the cloudlet. So, cloudlet was the paradigms. So, the idea behind the cloudlet is to place computers with the high computation power at the strategic location in order to provide both computation resources and storage for the user equipment in the vicinity. Now, the cloudlet concept of computing hotspot is similar to the Wi-Fi hotspots, but instead of internet connectivity, the cloudlet enables the cloud services to the mobile users. So, that is called computing hotspots, we can understand that. So, cloudlet provides computing hotspots. Now, the fact that cloudlets are supposed to be mostly accessed by the mobile user equipments through Wi-Fi connection is seen as the disadvantages, since the user equipment have to switch between the mobile network and the Wi-Fi whenever the cloudlet services are exploited. So, this particular aspect is going to be looked upon while this applying the edge computing to this scenario, that is mobile edge computing. Now, the quality of service of the mobile user equipment is hard to fulfill similarly in the case of mobile cloud computing, since the cloudlets are not an inherent part of the mobile network and the coverage of Wi-Fi is only local and limited with the support of mobility. Now, let us go and see more detail about that. So, the other option enabling the cloud computing at the edge is to perform the computing directly at the user equipment through ad hoc cloud, allowing several user equipments in the proximity to combine their computational power, thus processing high demand application locally. Now, to facilitate this ad hoc cloud, several critical challenges need to be addressed, finding the proper computing user equipment in the proximity while guaranteeing that process data will be delivered back to the source user equipment. Second is the coordination among the computing user equipment has to be enabled, despite the fact that there are no control channel to facilitate reliable computing. Third is that computing user equipment has to be motivated to provide their computing power to the other devices, given the battery consumption and additional data transmission constraints. Security and privacy aspects also are involved. So, now we will see another paradigm of edge computing applying to MEC, fog computing. So, the more general concept of edge computing when compared to the cloudlet and ad hoc is called the fog computing. So, the fog computing paradigm was introduced in 2012 by Cisco to enable the processing of the applications on billions connected devices at the edge of the network. So, the fog computing may be considered as one of the key enablers of Internet of Things and big data, as it offers. So, the following are the use cases or the examples. So, low latency and location awareness due to the proximity of computing devices to the edge of the network is one such advantage. Second advantage is that there is a widespread geographical distribution when compared to the cloud. Third important thing is that interconnection of a very large number of nodes, that is called IoT sensors, and support of streaming and real time applications. Now, moreover, the characteristics of a fog computing can be exploited in many other application scenarios, such as smart grid connected vehicles for intelligent transportation system or the wireless sensor networks. So, that was about the fog computing concepts. Now, from the mobile users point of view, the most notable drawback of previously mentioned edge computing paradigm is the quality of service, and this quality of experience for the users can be hardly guaranteed by the paradigms which we have seen in the previous slides. Since the computing is not integrated into the architecture of mobile network. Now, therefore, in 2014 the industry specification group ISG within ETSI, that is European Telecommunication Standard Institute, outlined the concept of mobile edge computing, which integrates the edge computing into the mobile network architecture. So, by this what we have understood is that, let us summarize our discussion, meaning to say that we have used several edge computing paradigm to solve this particular problem of bringing the compute and storage close to the user equipment by not including into the mobile network, out of the mobile network, using the cloudlet paradigm of an edge computing, or using the fog paradigm of an edge computing, or using ad hoc cloud. So, these particular things, what we have seen, that these particular things has the disadvantage that it is not going to satisfy the quality of service and quality of experience of the mobile of the users. Why? Because since this computing is not integrated into the architecture of the mobile networks. So, we are going to see next how are we going to integrate, the computing into the architecture of mobile network, and thereby we are now going to talk about mobile edge computing. So, let us get started about the architecture of a mobile edge computing. Now, several MEC concepts are built upon with the purpose to smoothly integrate the cloud computing capabilities into the mobile network architecture. Now, we will see what are those concepts which can integrate smoothly the cloud computing capabilities into the mobile network architecture. Now, we shall discuss some of the architecture which can be proposed or being explored of MEC, and let us name them, and then we are going to discuss it in great details. So, the first one is called small cell cloud. So, there are that mobile networks are having small cell, femtocell, microcell, and so on. So, we are going to discuss that how these cell can be enabled with the computing and the storage capabilities, so that user equipment can get these particular resources very quickly. That is how are we going to reduce the latency and how the energy can be saved. Second type of architecture for MEC is called mobile micro cloud, MMC. Third one is called fast moving personal cloud, fourth one is Follow Me Cloud FMC and Consort and ETSI MEC. Finally, this is the standard, that is ETSI standard has been evolved out of all of them, understanding all the architectures. MEC ETSI has given its a standard architecture for MEC. Now, coming to this MEC architecture, talking about small cell cloud SCC. So, that was the first in that particular list which we have seen, small cell type of architecture. So, small cell cloud or SCC is a precursor or it is a first architecture proposed for MEC. Let us trace it. So, the basic idea of small cell cloud or SCC was introduced in 2012 by European project called Tropic. There it is aim is to enhance the small cell like microcell, picocell, femtocell by additional computation and storage capabilities that we have already told you. Now, the cloud enabled small cell, enhanced small cell supports the edge computing as well. How? So, the cloud enhanced SCENBs can pool their computing power exploiting two technologies. One is called network function virtualization paradigm. Now, the computing resources are virtualized by means of virtual machines and often located at small cell, enhanced small cell, that is small cell cloud. Now, because high number of SCENBs is supposed to be deployed in the future mobile network, the SCC can provide enough compute power for user equipment, especially for services and applications having the stringent requirement on the latency. So, we are going to see whether this large scale deployment of this kind of architecture called small cell cloud, whether it is going to suffice or we have to look upon few more alternatives. So, in order to fully and smoothly integrate the SCC concept into the mobile network architecture, a new entity denoted small cell manager is introduced to control the SCC. So, we are going to see that in SCC it involves the small cell manager to control the SCC. Now, why? Because we are talking about so many deployments of small cell clouds. If it is possible, then all of them how to manage. So, it requires a control of SCC through a centralized service which is called the small cell manager. So, here you can understand that small cell manager will control all of SCCs. Since these SCENBs can be switched off and on, they can be switched off and on at any time. The SCM performs dynamic and elastic management of compute resources within SCC. So, SCM is aware of overall cluster context both radio and the clockwise, and decides where to deploy the new computation or where to migrate an ongoing computation to optimize the service for the end user. So, we have understood about small cell architecture. Now, let us see that in this details what we have talked about small cell cloud. So, small cell manager, this is called the control manager. A small cell manager can be deployed, may be deployed in a centralized manner. So, there is only one small cell manager, it is centralized either as a standalone SCM located within radio access network close to the cluster of the SCENBs or an extension to an MME. So, this is a part of the core network. So, either so you can see that the placement has a choice whether it has to be close inside RAN or it is in the core network. So, this is clear that it has to be deployed in a centralized manner. So, here it is shown more details of it in the figure. Now, SCM can be deployed in a distributed hierarchical manner also. So, if let us say that SCM is distributed, then what are the components involved in it, where the local SCM can be a local SCM or it can be a virtual SCM. So, that is another way, that is called VLSCM. So, either way they can be deployed in a distributed manner. So, it manages the computation and storage resources of SCENB's cluster in the vicinity, while the remote SCM, this is called remote SCM, located in the cloud network or in the core network, has resources of all SCENBs connected to the core network at its disposal. So, this is the hierarchical distributed hierarchical SCM configuration, and previously we have seen the centralized SCM configuration. Now, we are going to see the next architecture possible for as an MEC architecture. So, the next architecture is called mobile micro clouds. So, this is the mobile micro cloud that we are going to see now. So, the mobile micro clouds or MMC allows the users to have instantaneous access to the cloud services with low latency. So, here you can see that this is the ENBs and which is the base station. Over the air, these user equipments are having the first mile connectivity with this ENBs, and this MMC provides these kind of resources there itself, that is very close by to ENBs. So, user equipment will get the access with a low latency. So, that is what is written over here. So, MMC allows the users to have instantaneous access to the cloud services with a very low latency. Now, SCC, while in SCC the computation and storage resources are being provided by interworking cluster of SCENBs. So, the user equipment exploit the computation resources of a single MMC, which is the typically connected directly to the wireless base station, that is what we are seeing over here. So, the MMC concept does not introduce any control entity here, whereas SCC requires a control entity into the network, and the control is assumed to be fully distributed in the similar manner as VL SCM solution for SCC that we have seen in the previous slide. So, MMCs are interconnected directly or through the backhaul in order to guarantee service continuity if user equipment moves within the network to enable the smooth VM migration among MMCs. So, you can see that if this particular user equipment moves here to another base station vicinity, this is called the mobility, then also it is supported here in this particular case called mobile micro clouds. Now, we are going to see the next MEC architecture, which is called a fast moving personal cloud or MoBi-SCUD. So, MoBi-SCUD architecture integrates the cloud services into the mobile network by means of a software defined network and network function virtualization technologies, while maintaining the backward compatibility with the existing network. So, it applies two technologies, one is called software defined networks, which is shown over here, and the other is the network function virtualization technologies, which is shown here in this particular way. Now, when compared to SCC and MMC concepts, the cloud resources in MoBi-SCUD are not located directly at the access nodes such as SCENB or ENB, but at the operator's cloud located within the RAN or close to the RAN. So, here you can see that particular concept, that this particular cloud is now using or accessed with the help of the transport, which is virtualized, called software defined network, and it is inside the RAN, but it is not very close to the ENBs. So, these clouds are assumed to be highly distributed, similarly as in the case of SCC and MMC, enabling the cloud service to all user equipment in its vicinity. Now, MoBi-SCUD introduces new control entity, and that is called MoBi-SCUD control or MC. So, here you can see that MoBi-SCUD control is there. Which interfaces with the mobile network, SDN switch, this is interfaces with the mobile network and software defined network and the cloud. So, this scenario if you see, so it interfaces with the mobile network, it interfaces with the software defined network switch and the cloud. Basically, this MC or MoBi-SCUD control has two functionalities. The first one is monitoring control plane signaling. So, monitoring control plane signaling messages exchanged, between the mobile network elements to be aware about the user equipment entities. So, this particular communication is happening. Then second aspect of this functionality of this MoBi-SCUD control is called orchestrating the route and routing data traffic within software defined network enabled transport to facilitate the application offloading and the VM migration if the user equipment moves throughout the network. So, this makes this quite flexible and the network programmable in this particular mechanism. Now, the next architecture of MEC is called follow me cloud or FMC. So, the key idea of follow me cloud is that the cloud services running at the distributed data centers follow the user equipments as they roam throughout the network. So, here you can see that when compared to the previous MECs concepts, the cloud and storage power is farther from user equipments into the core network of the operator. Now, nevertheless, while previous MEC concepts assume rather centralized cloud network deployment, the FMC leverages from the fact that the mobile operator need to decentralize their networks to cope with the growing number of user equipments. Now, the three centralized core network used in the current network deployment is assumed to be replaced by the distributed one, that is shown over here, and for convenience of the mobile operator, the DC may be located at the same place as the distributed GW. So, again we are explaining this through this particular diagram. So, what we are seeing over here is that in the RAN you can see that there is this particular edge computing, that is compute and the storage is not present, but rather it will be managed with the help of a decentralized CN. And to facilitate that, it will be forming a distributed cloud within that particular network. So, the key idea of follow me cloud is that the cloud service is running at the distributed data centers. This is the distributed data centers. Follow the user equipments as they roam throughout the network. So, when compared to these previous MECs, what you have seen is that compute and storage power is moved farther from the user equipment. So, the distance is involved. Nevertheless, while previous MECs assume rather centralized CN deployment, the FMC leverages the fact that mobile operators need to decentralize their networks to cope with the growing number of. So, therefore, it uses the decentralized CN. 3 CN were replaced here with a one distributed one. So, for convenience of mobile operator, the distributed control or may be close at the same place. So, let us see about FMC. Here it introduces the new entity into the network architecture called DC and GW mapping, that is the data center, distributed data center and GW mapping entity and an FMC controller. So, this can be either functional entities co-located with the existing network nodes or software run on any of the data centers. So, DC oblique GW mapping entities map the DC to the distributed GWs S or P here, which is shown over here according to the various metrics such as location or a hop count between DC and the distributed CN in a static or dynamic manner. So, FMCC manages DC's computation storage capabilities, storage services running on them, and decides which DC should be associated to UE using the cloud services. So, FMCC may be deployed either centrally or hierarchically with global FMCC and local FMCC for better scalability. So, FMCC itself may be decentralized, controlled by omitting FMCC altogether. In such a case, the DCs coordinate themselves in a self organized manner. Now, the next architecture is called concert. So, the full form of concert is concept converging cloud and cellular networks and cellular systems. So, concert assumes to exploit NFV principles and SDN like the above mentioned solutions. So, the computing storage is utilized by conventional mobile communication and cloud computing services as virtual resources. Now, the control plane consists of a conductor, that is what we are seeing here in the figure, which is a control entity managing the communication, computing and storage of the concert architecture. So, the conductor may be deployed centrally or in a hierarchical manner for better scalability, and data plane consists of the radio interface equipment and physically representing the ENBs, SDN switch and the control and the computing resources. So, the computing resources are used for both baseband processing, similarly as in CRAN, and for handling and application level processing. So, the concept proposes hierarchically placement of resources within the network to flexibly and elastically manage the network and cloud resources. Local servers with a low computation power are assumed to be located directly at the physical base station, and if local resources not available, then regional or even the central servers are. Now, let us see the IIT MEC. So, IIT is currently deeply involved in the standardization activities in order to integrate MEC in the mobile network. So, MEC can be exploited either by UE application located directly in the UE or by third party customers via the customer facing portal, that is what is shown over here. Now, both UE and CFS portal interact with MEC system. Here you can see through MEC system level management. Now, MEC system level management includes a user application lifecycle management, user application cycle management proxy, which mediates the requests such as initiation, termination or relocation of the user application within the MEC system to the operation support system, that is OSS. Now, OSS decides if the requests are granted or not, and the granted requests are forwarded here to the mobile edge orchestrator. Now, let us see more details of IIT. So, the mobile edge orchestrator here is the core functionality in MEC system level management, as it maintains overall view on the available computing, storage and network resources in MEC services. Now, mobile edge orchestrator allocates the virtualized MEC resources to the applications here, that is shown over here as MEC servers. So, orchestrator also flexibly scales up and down available resources, and MEC system level management is interconnected to MEC servers. So, therefore, MEC system level management manages the life cycle. MEC system level management is responsible for allocation, management and release of the virtual resources, and MEC server represents the virtualized resources, hosts the MEC application running on as virtual machine on top of the virtualization infrastructure that we have already seen over here. So, if we see this particular architecture comparison, what we found is that the control, how it is done, sometimes it is centralized, and how the control placement is done, that we have seen, and the computation and storage placement, that we have seen different ways in different methods. So, what are the MEC deployment options? So, MEC services will be provided by MEC servers. Storage, there are several options where MEC and server can be deployed in the mobile network. The first option is to deploy MECs directly at the base station, similarly as in the case of SC. The second option is that MEC servers at the cell aggregation sites. A third option is to move the MEC server further from and locate it at the edge of the core network. Now, the selection of MEC server deployment depends upon many factors such as scalability, physical deployment, performance, delays. For example, the first option with fully distributed MEC deployment will result in a low latency, since the UE is in the proximity of E and B's, hence in the proximity of. Contrary, the UE is exploiting the MEC server located in the core network will inevitably experience the longer latency, could prevent the use of real time applications. So, let us conclude this. In this particular lecture, we introduced about MEC concepts proposed with the vision of MEC developed under IIT standardization. Now, we have seen two common trends followed by the individual MEC solution that bring the cloud to the edge for of mobile network. So, first trend is based on the virtualization techniques, which often exploits NFV, network function virtualization principles, and the second trend is the decoupling the control and data plane by taking the advantage of software defined networking paradigm. So, the use of SDN in MEC is also in line with the current trends in the mobile network. Now, regarding the control signaling, the MMC and MOBI SCUT assume fully decentralized approach, while SCC, FMC and CONSORT adopt fully centralized approach or hierarchical control for better scalability and flexibility. Thank you very much.